Hello. So another method in index set splitting is loop peeling. So loop peeling is a very simple method and it is used when source of dependence is in single iteration. So from single iteration only all dependence are emerging, then this method is used. To understand this, take example, a very simple example. Do I is equal to 1 to n. Inside this loop which is executing n number of times, we have only one statement, which is a of I is equal to a of I plus a of 1. So when this execute first time, then a of 1 is calculated by using a of 1 plus a of 1. So on left hand side you will be having a of 1, on right hand side you are having a of 1 two times. So this is how a of 1 is calculated. In second iteration I is equal to 2 and a of 2 is calculated by using a of 2 plus a of 1. And here meaning is this a of 1 should be the value which is calculated in previous iteration. Then in third iteration a of 3 is calculated by using a of 3 plus a of 1. So you can see here that in every iteration from 2 to n, you are using a of 1 which is calculated in first iteration. So here how many dependencies are there? There are n number of dependents and every dependence is starting from the first iteration of loop and going to different iteration of loop from 2 to n. So you can say that source of iteration is a single iteration and here it is a first iteration. So if source of dependence is single iteration, then we can peel off that iteration out of the loop. So if we peel off this iteration out of the loop, then this loop will be transformed to, you see, a of 1, this statement, first statement is moved out of the loop. So before loop you will be having a statement a of 1 is equal to a of 1 plus a of 1 and that is calculated, this is to be calculated in the first iteration, and then loop will actually start from 2 because first iteration is already calculated by the statement which is moved outside the loop. So loop will now run from 2 to n, and inside that we have the same statement a of I is equal to a of I plus a of 1, but in this loop there are no dependence. Within the loop there are no dependence. A of 1 is a loop constant. A of 1 is calculated before start of the loop and its value will not going to change in any of the iteration. Okay, so inside the loop all iterations are dependence free and we can vectorize it. So if we vectorize this loop, then the program would be as given below. A of 1 is equal to a of 1 plus a of 1, this is statement, and then loop will be transformed into vector instruction. A of 2 to n is equal to a of 2 to n plus a of I. So this method is known as loop peeling. When source of iteration is first statement or last statement, then this can be very easily applied. If it is a first statement, if source of dependence is first statement, then that can be moved before the starting of the loop. If source of the dependence is last statement, then that statement can be moved after the loop. But even if source of dependence is a intermediary instruction, if it is a iteration in middle, not the first and last one, then also we can apply loop peeling, but then we have to do the section splitting. So suppose if source of iteration, source of all dependence is say iteration number 50. So if iteration number 50 is source of all dependence, then we'll first execute first 49 instruction 1 to 49. Okay, first 49 iteration would be executed, and then 50th instruction would be executed in sequence separately, and after that from 51st to n remaining iteration would be executed in another loop. So first loop would be vectorized, then 50th iteration would be executed, and then remaining part of the loop would be vectorized. Okay, so this is all about loop peeling.